All right, today we are going to pull back the curtain on a really fascinating AI model from OpenAI. It's called CLIP. And on the surface, it seems to do something almost magical. It connects pictures and words in a way that just feels intuitive. But how does it really work? Let's get into it. So let's start right here. You see this picture. A normal AI model might just spit out the word guacamole, simple enough. But look at what CLIP says. A photo of guacamole, a type of food. Now that's a lot more descriptive, isn't it? It's a full sentence. And then you see this. It's a completely different kind of image, right? A satellite photo. And yet, the exact same AI looks at this and, again, gives this incredibly specific, full sentence description. A centered satellite photo of permanent cropland. And here is where it gets really wild. This one model can jump between all these different tasks, identifying food, analyzing satellite images, you name it. And it does it all without ever being specifically trained for any of them. This is what we call zero-shot classification, and it's a huge deal. So that brings us to the big question, the real puzzle we're trying to solve here. How on earth can one single AI be this flexible? How can it just understand so many different things right out of the box? To really get why CLIP is such a breakthrough, we kind of have to take a step back and look at how things used to be done. The old way, well, it was a lot more rigid. Okay, so on the left, you've got the classic approach. Think of it like a machine that can only sort things into a few pre-labeled bins. You show it a million cat photos, it learns to put new photos into the cat bin. But that's it. Ask it about something else, it's clueless. CLIP, over on the right, has a way bigger ambition. It's not trying to learn a fixed set of labels. It's trying to learn the actual relationship between what we see and how we talk about it. So how did the OpenAI team pull this off? Well, it all boiled down to a really clever new training method. This was the big aha moment. The secret sauce is something called contrastive learning. So instead of just asking the AI, hey, is this a dog? You give it a much more interesting game to play. You show it a whole batch of pictures and a whole batch of captions, and you basically tell it, play matchmaker, figure out which caption goes with which photo. It's not memorizing answers, it's learning to see the connections. It basically works in 3 steps. First, you take a bunch of images and their captions and you turn them into lists of numbers, or vectors. Think of it like creating a unique numerical fingerprint for every image and every bit of text. Then, step 2, you compare every single image fingerprint to every single text fingerprint. And finally, the most important part. The model learns to do one thing. Make the similarity score for the correct pairs as high as possible and the score for all the wrong pairs as low as possible. And this table here shows that goal perfectly. See that diagonal line? Those are the correct matches. The image of the pup lines up with the text Aussie pup. The model's entire job during training is to make the numbers on that diagonal go way, way up and make all the other numbers go way, way down. It's just one giant matching game, played billions of times. Okay, so the theory sounds really elegant, but the big question is, does it actually work in the real world? Let's check out the results. Because of this training, CLIP gets a superpower, zero-shot classification. This is so cool. When you want to classify a new image, you don't have to retrain anything. You just give it the picture, and then you give it a few text prompts like a photo of a dog or a photo of a cat. CLIP then tells you which prompt is the best match. It's that simple. And the performance? It's just stunning. This chart here is comparing CLIP, with no task-specific training, remember, to a really strong standard model that was fully trained for these jobs. And on a bunch of these datasets, zero-shot CLIP is actually better. It's even competitive on the famous ImageNet dataset against a model that was trained specifically on ImageNet. That is just incredible. And what's more, CLIP turns out to be way more robust. See, a lot of older models are brittle. They memorize the patterns in their training data. So if they only saw photos of bananas, they get totally confused by a sketch of a banana. But because CLIP learned the concept of a banana from all kinds of text descriptions on the internet, it handles these variations so much better. Now, this new way of doing things comes with its own funny challenges. Since everything depends on the text you use, the researchers often had to come up with clever descriptions, which led to this amazing footnote in the actual paper where they admit one of the authors basically had to become a temporary expert on flower species and German traffic signs just to write good prompts. It's a great reminder that with this kind of AI, the words you choose matter a lot. Look, this isn't just some cool academic trick. CLIP really marks a huge shift in how we build AI vision systems, and it has some massive implications for all of us. So what should you really take away from all this? Well, first, it democratizes AI. Suddenly, you don't need $1 million to label a dataset. You can build a pretty good classifier for almost anything. Second, it gave birth to a whole new skill, prompt engineering. Figuring out the best way to ask the AI a question is now a crucial job. Third, we get AI that's more robust and less fragile in the real world. And finally, and this is a big one, this is the foundational tech for creative AI. This deep understanding of images and text is exactly what powers models like DALL-E to generate incredible new pictures from just a description. So, for the first time, we're not just training computers to recognize 1,000 specific things. We're giving them a tool to understand our language and connect it to anything visual. The only real limit now is our own imagination. So the question is no longer just what can AI see, but what will we ask it to see next?